Welcome to my coastal management case study presentation, Timmendorf, Integrated Coastal Flood Risk Management. My name is Gerald Schernewski. I'm head of the Coastal and Marine Management Group at the Leibniz-Institute for Baltic Sea Research in Warnemünde, Germany. And at the same time, I'm professor at Klaipeda University. What is the situation? Timmendorf-Scharbeutz are tourism resorts located in Schleswig-Holstein at the Baltic Sea. So this is the northernmost part of Germany. And the challenge is that most of the area, about 12 square kilometers, are lowlands, are less than 3 meters above the sea level and have the potential risk of being flooded. But at the same time, there are 5,700 inhabitants living there, about the same number of tourism beds. And this means we have a lot of economic values located in this area, 1.7 billion euros. What was already obvious in the 1990s was sea level rise, and that this would go on and possibly accelerate because of climate change. So something had to be done. So the background conditions in summer 1999. The coastal flood defense was deficient. The wall was only 2.2 meters above the sea level. And responsible for coastal flood defense in this federal state are the municipalities. The state administration gives technical advice and financial support. The local population is very skeptic about storm surges, about sea level rise, because heavy, dangerous storm surges are very rare at the Baltic Sea. It's a microtidal sea. On the other hand, the local people asked for beach nourishment to replace the eroded sands from the beach by offshore sand. And they wanted a protection by groin systems, pile rows. So the state then said, well, as a prerequisite, we need a comprehensive protection scheme, not only taking into account coastal protection but flooding at the same time. And the locals agreed, but wanted an active involvement. In the first step, a stakeholder mapping took place. 65 persons were invited to a first conference, and this was organized by the ministry but run by a consultant company. And they agreed on a very comprehensive and new approach. In the following year, in 2000, altogether 7 stakeholder meetings took place with a maximum number of 25 peoples. And they were moderated by a consultant company. And this consultant company applied a stepwise sensitivity model developed by Professor Wester. And this covered 5 steps. So in the first step, the local people, during a meeting, had to characterize their region with variables. A variable such as economic power or the quality of life. Then they had a look, how do the variables interact? What is the dependency between the variables? Because the number of variables was too high, they defined a submodel that was strictly focusing on the topic, on coastal defense and protection. And in the next step, 5 scenarios, potential sets of measures were defined that would solve the problem. And subsequently, a simple model was established that simulated how effective these scenarios protect the area and affect the variables. So it started with a characterization of the region, variables and dependencies. If we have a look at the number of guests, so this has a strong effect on the economic power of the area. And since several people work in tourism industries, they have a medium effect on the degree of employment. On the other hand, the quality of living is not affected by the number of guests. So this very comprehensive matrix with 17 variables was too difficult to implement in a model. So a simplified version was developed. Everything focused on flooding risk and on the solutions, on flood defense and coastal protection. And the model established the relationship between the variables. So how are intact nature, living space, tourism services, number of guests, or the attractiveness of beaches affected by the flooding risk? And how is this modified by the measures? 5 scenarios of measures were developed. Number 1 was simply to do nothing. Number 2 included only coastal erosion protection measures, beach nourishment, wooden pile rows, the groin systems. Number 3 was a steel wall behind the beach as a flood protection. Number 4 was a combination of 2 and 3. And number 5 was a dike directly on the beach. Advantage of the dike is that the costs had to be entirely covered by the state, and the same is true for maintenance cost. So a safe and cheap solution for the locals. The models started with the estimation of the risk of flooding. So this describes the frequency of flooding and the damages. And this is then related to the scenarios and the single variables. And this allowed very simple simulations. This is the simulation for scenario 4, so combining coastal erosion and flood protection measures. And the calculation took place in 5-year time steps. As soon as the measure is implemented, we see that the green line drops. Intact nature, because the beach and the coastal dune system became entirely artificial. But the other variables increased. So tourism services became better, number of guests, attractiveness of beaches. They reached a high level and only after 40 years decreased, because then climate change-induced sea level rise causes erosion and the destruction again. This is merely qualitative. There is no data really behind. There is no scientific validation. It more or less reflects how the people perceive their region. And the idea of this very simple model approach is to structure a discussion process. So after the procedure, people were invited to a public meeting, and the group was quite happy with the process, with this guided modeling approach, and they were able to agree on solution. Number 4, they wanted erosion control, meaning beach nourishment and pile rows, together with flood protection, the wall behind the beach. But the people said, well, we want to be involved in future in the planning and implementation process of these measures. So we can summarize that from the perspective of the state authority, this worked very well, because there was a solution obtained and an implementation process could take place. And this is how it looked. This is the building of the steel wall behind the beach. Altogether 12 kilometers had to be renewed. And this caused costs of 30 million euros. This is how it looks after it was ready. So the situation in 2015. The wall protects the town, and the wall is interrupted by gates, and these gates are mobile to allow the access to the beach. In areas where buildings were close at the beach, different structures had to be used for the protection, and on more remote and more natural areas, the entire scheme was hidden under artificial dunes. So this gives an impression how it looks like. And if we carry out now a SWOT analysis, strengths, weaknesses, opportunities, and threats, and we start with the strengths. So there was an active involvement of the local people, a very systematic approach, and the results were accepted and very transparent. Opportunities were that the people became aware of the problems of sea level rise, of increasing risks, that they became aware of their own responsibility, that the municipalities have to do something. And there was a good acceptance of the solution at the end. But this approach has weaknesses as well. Compared to the number of people who are living in the area, the number of involved participants was low. 7 meetings took a lot of time. So it was tiresome and time-consuming, and everything depended that the people volunteered to take part in this process. A major threat was that it may have happened that they would come to the solution and do nothing, to reject coastal protection. This would have been a major problem for the ministry. And there is another risk that because of the many meetings, that there is a lot of interest. That the number of participants is further decreasing during the process. And one major problem, the slow implementation. So that it took place only 7 years after the discussion. So we have different people responsible at that time, and the acceptance is then reduced. But despite these weaknesses, we can say that Timmendorf is a good example for the application of a systems approach in coastal management. So we see this as a best practice example. And with this, I'd like to thank you for your attention.